In this question, we are going to think about binary regressor, and also the instrument is binary. So we have a simple linear model, but x is binary, so it's just whether x equals to 1 or 0. And we do not impose the exogeneity assumption here. Instead, when x equals to 1, average of u is gamma, and when x equals to 0, average is delta. So the unobserved u can be different when x is different. The first question is about to find observationally equivalent parameter value. By the way, I will focus on beta. Actually, alpha is not that difficult. It is normalization. When you add c, then you can just take minus c. So gamma minus c or alpha plus c will generate another alpha. That's too simple. So let's think about beta. The idea is pretty simple, again, as usual. In the binary case, it is just two information. We only have two information, right? And we write this as, beta plus gamma, and this is alpha 0 plus delta, okay? So that means beta is, also, we know this side is observed part. So if you take difference between them, then I will write this as mu1 minus mu0 on the left hand side equals beta 0 plus gamma minus delta, right? That means if you do not know gamma and delta, and if you change what matters to beta is the difference. So this is observed. You can identify this side, right? So to identify beta, you just need to restrict this guy, okay? Then using that idea the other way, so suppose that gamma 0 and delta 0 are the true values. And now consider any value gamma tilde and delta tilde such that gamma tilde minus delta tilde is different from gamma 0 minus delta 0. Okay? Then I will define beta tilde in the way that beta tilde plus such that beta tilde plus gamma tilde minus delta tilde equals beta 0 plus gamma 0 minus delta 0. Right? So that means as long as these are the same, we have this equation. So these parameters satisfy these equations, right? Just replace alpha tilde, like beta tilde, and gamma and delta here, right? So always you can find such gamma, delta, and beta, so that will generate an observationally equivalent parameter values. Okay, that was A. And in B, you make a wrong exogeneity assumption that the average of unobserved part is the same across X. But that was wrong. So then let's find the misspecification bias. So now, if you assume, like I will start from here. So now you see mu1 minus mu0 equals beta 0 plus gamma minus delta. But if you assume expectation of u x equals to 1 equals u x equals to 0, if they are the same, that means gamma minus delta is 0, right? So you identify beta using the difference, okay? So that means this is your parameter, and this is left hand side is your estimand. But they are different, okay? How different are they, right? The difference is actually, but under the true model, mu1 minus mu0 is beta 0 plus this guy. Okay, actually, no algebra is needed. Right? So delta minus gamma minus delta is the misspecification bias. Right? So the simplest version of misspecification endogeneity problem. And C, I derived. I showed you like I did B and C at the same time. All right. So when gamma equals to delta, then mu1 minus mu0 identifies beta, but it is misspecified. Now let's think about instrumental variable that is also binary, and it satisfies this condition. How can we utilize that? So we now have ui given zi equals to 1 equals expectation ui given zi equals to 0, right? So to do that, first I will calculate this and this. Okay, if you do that, pretty simple, alpha 0 plus expect beta 0 expectation xi given zi equals to 1 plus expectation ui given zi equals to 1. And the second term is alpha 0 plus beta 0 times expectation xi zi equals to 0 plus expectation ui given z equals to 0, right? And here you subtract them. Subtract the bottom from the above. Then you get expectation y given z equals to 1 minus expectation y given z equals to 0 equals beta 0 expectation x given z equals to 1 minus expectation x given z equals to 0. And the last terms will be cancelled out when you subtract them. So then, if this is not 0, then you will get beta equals to y given z1 minus y given z0 divided by x given z1 minus x given z0. Okay, of course, you need the assumption that the denominator is not 0, right? Expected value of x must change when you change z from 0 to 1. I forgot to mention that, but this is pretty common in my problem set.